How's it going, Precalc kids? Today we are going to look at 3.3, do it all in one day, logarithmic functions and their graphs. Today should be a complete review. Okay, so let's talk about it. If x is greater than 0, 0 is less than b, b is greater than 0, and b is not equal to 1, then this right here is the noteworthy part, guys. Thanks for the fart noises, Jude. But we'll keep going. Okay, what this says is y equals log base b of x. If this is true, then b to the y equals x. Okay, take this to that power equals your x. For example, if I have log base 10 of 100, what's that going to equal, guys? That's going to be 2, because 10 second equals 100. Next slide. You don't have to draw this graph, just think about it. The reason why log was created was to build houses? No, it was to have an inverse for your exponentials. If log wasn't made, there wouldn't be an inverse. Without an inverse, you can't get from one to the other, okay? You can see, remember, inverse is reflected across the line, y equals x. Probably come up around exam time. Okay, properties of logs. Definitely noteworthy. There's 4 of them. They're basic. What that pretty much means is your log base b of 1 is 0 because anything to the 0 power is 1. So if you see log base 100 of 1, that's going to be 0 because 100 to the 0 is 1. Anything to the 0 is 1. Okay? Your log base b of b equals 1 because b to the 1 equals b. So again, if I put log base 100 of 100, that's going to be 1 because 100 to the first power is 100. Log base b of b to the y equals y because b of y equals b of y. Well, yeah. Log base 3 of 3 to the 4th, that equals 4 because 3 to the 4th equals 3 to the 4th. And b to the log base b of x, remember, equals x. That's because it's an inverse, guys. Remember, plug an inverse into the original function, you get out x. So that'd be something like 3 to the log 3 of 100 equals, well, 100. That's all there is to it, guys. Okay, let's do some examples. Log base 2 of 8 equals, well, you gotta ask yourself, 2 to what power equals 8? Well, 2 to the 3rd equals 8. Next one. Log base 4 of cube root of 4. This one, remember, what's cube root of 4, guys? Isn't that the same thing as 4 to the 1/3? Which means it's a third, because we're taking 4 to the 3rd power. Okay, 1/9. Here's my hint for you guys for these ones. Take your 1/9. Isn't that equal to 9 to the negative 1? Our base, so is 3. Could I make that into, I don't know, 3 squared to the negative 1? Now an exponent to an exponent, you multiply them, so it's 3 to the negative 2. So this means 3 to the negative 2 equals 1/9. Let's do another one here. Log base 109 of 1. Well, anything to the 1 is 0, guys. That's one of our properties from before. Log base 8 of 8. Again, guys, that's saying 8 to what power equals 8. You know, 109 to what power equals 1. Now this one's our good old rule. These kind of cancel and you just get 12. Okay? Halfway there. By the way, if you didn't write this down, don't be a fool, as Derek would say. Okay, common logarithm, base 10. Logarithms to base 10 are called common logs. If you look at your calculator, there's going to be a log button. If you push it, a log falls on your head. No. Whenever you push log, you're actually in log base 10. Okay? So log button is log base 10. So none of these problems before, you can do in your calculator because none of them are base 10. These ones you can because you have that. Okay? So out of all the noteworthy, this is it. Log base 10 of x. Okay? Again, I guess right here too. So some things to keep in mind. Guys, these are same rules as before, so you don't have to write them. Just keep in mind, you can plug this in your calculator. What's log of 100 then? Well, that means 10 to what power? Equals 100, 10 squared. And you can test it in your calculator, you can test it on the online calculator, scientific calculator. I guarantee you'll get it right. Guarantee. Okay? Solve this equation by changing it to exponential form. Log of x equals 4. So we gotta find x, guys. It's noteworthy. Remember, this log, no number underneath it. But this is actually a 10, right? This says 10 to the 4th equals x. 10 to the 4th is 4 zeros equals x, and you're done. That's all there is to it. Okay, here's something noteworthy. Not the box, but this right here. Ellen, one of my favorite TV shows, no, is log base e. Okay, so if you see, even let's grab this, ln of e, that's saying log base e of e, which is 1, because e to the 1 equals e. Okay, keep that in mind. You're going to need to use this to solve some problems that we're dealing with exponential growth, okay? So ln, that's a button on your calculator too. ln, natural log. Why is it ln and not nl? I don't know. Don't ask me. It's the opposite of Duraflame, which is the unnatural log. Think about that one, guys. It's a think a man's joke. Last slide. It's just one of those graph ones. If you take a look at the graph of ln of x, okay. Sorry guys, a little hiccup here in the system. I had to pause and charge my Mobi pen. So if we look at natural log of x, it looks like this. We have a vertical asymptote at x equals 0. Because think about this, guys. Can you take e to a power and get 0? No. So there's a vertical asymptote at 0. So when you shift stuff around, you're actually shifting around that asymptote, okay? So when we look at the graph of natural log of 2 minus x, let me rewrite that. Isn't that natural log of negative x plus 2? Okay? That plus 2 is going to move our asymptote to the left 2, right? So our new vertical asymptote is going to be x equals negative 2. Okay? Now that negative x, that is going to reflect us across the y-axis. Okay? So what our new graph is going to look like is this guy right here. Because we're going to we moved our vertical asymptote to y equals negative 2, and we reflect over y axis. Okay? That's all there is to it, guys. That's where we're going to end it today. Enjoy.